Hockey dokie! Welcome to part two of our look at the binary counter. And in this episode, we will convert that counter into a um, little engine specifically designed for use on an elevator, although this will work for anything where we're attempting to move a set number of blocks. This could easily be modified to work on, say, a melon farm. Although there's a million versions of melon farms out there, and I'm kind of hesitant to do that. Um, Elevators are much more rare. So I thought that would be a good tackle. And then when we're done with that here at the tail end, we'll get the tutorial out of the way first because I know people don't always like listening. We will take a look at ye old memory array and kind of give some differences between this engine and this when used as an engine. So yeah, here we go. Right. We're going to start off with a block and a button. This is actually going to be your input, so eventually we would have a line running into here. But for our purposes right now, we will keep a button. This is going to be the in circuit, and this is going to be the out circuit. So this will power everything on the outside of it here. What we're going to do next is something that's going to look real familiar for you. Let's do this in blue, I guess. This is just going to be our pulse limiter. And then for this engine, we're actually going to extend this pulse limiter out one. So this is new right here, nothing different. We're just extending it out so that everything fits neatly. And from there, what we're going to do is build our little 8-bit array here. So that is this guy. So everywhere there's green, we're going to want to do repeaters. And then for same reasons that I told you last time, we're just going to use blue wool just so we can keep it separate. So now we should have our neat, you know what I forgot? Redstone. There we go. Nice little array. So what we're going to build right here then on the orange circuit is just going to be, to start with, another pulse limiter. And we're building another pulse limiter here because you can take the pulse from right here, but this, when you do it, tends to get messy. The wiring does not fit as neatly. I don't feel like one piston is really going to hurt us all that much. So yeah, there you go. Same as we did over there, we're going to extend these out twice, except on this one we want to add a little bit of delay, so 4 ticks delay here on that repeater. We'll come around here then, and side of the repeater, got a block, and then we're going to extend this out 4 more so that we're right here on the side of where the pistons will kick it out. And then every other one just like that. Now we want repeaters into those blocks, and then link them all up with some redstone. So what we've done then, pulse limiter delayed a little bit. This delayed repeater will then power the redstone link, and then these repeaters in turn will attempt to power blocks that are here. And then obviously when there are no blocks, when these 3 are down, then no signal will carry over. On the other side, we are actually going to make a mirror image. So 2 blocks, cut that one out, 1 more out, and just a mirror image of what we did on that other side, just like that. This time, though, we actually want repeaters facing outward. We want these to go ahead and pick up the signal, and then again link them all up. Yeah, looking good. Almost done. Last thing then, we're just going to bring this line down, and now down here in the corner, we need a little bit more delay. We need to delay this so that we're not trying to run everything when these pulse limiters are still active. So a full 6 or 8 tick input from a button requires more delay here. If you've got a signal coming in that will be shortened, not a constant type of thing, then these delays here can actually be shorter. So anyway, for now, 4 ticks here, 4 ticks here, and link them up. So now, when we start our engine then, this is going to just continue to run until everything is down. Yep, so this is a nice little engine again. Going to run for a set number of iterations, and when these blocks are no longer up, no power comes across, so no pulse here to turn everything on again. So, neat little engine. Maybe a few too many repeaters, but for a survival multiplayer setting, especially if we're going to have some semblance of lag, I like a measure of control. So I have used repeaters here to maintain that control. Really, on this side, we could use redstone in place of these. You don't have to have repeaters, and then again down here, there's ways to modify. But I don't think that's too bad, not too expensive. Again, rules of Romedy, I want this to be lag-proof, idiot-proof, and I want this to be reasonably cheap to build in a survival setting. So, yep. This right here, then, is going to act as output to things. We can also, if we wanted to, carry something off of the this right here, as this is only going to run when there is an input. So we've actually got a couple options depending on what you want it to do. But there we go, pretty much done. So yeah, this will, in the tutorial portion here, we're going to talk about the memory array, this monster that we have built here, and kind of contrast around. So if you want to hear that, stick around. Otherwise, thanks for watching. Right then, this is ye old memory array. Again, I originally saw these from C&B Minecraft, building digital clocks. These things are actually very, very useful, very helpful. However, some differences that we're going to talk about here. So we'll go turn this guy off. There we go. So this, since we count in binary, this guy here, we can only do powers of 2. So 1, 2, 4. I've added another one here. This would actually be 8. And so when we're adding up numbers, this would kind of limit us in terms of what we can actually do. So yeah, you can't count everything here. Whereas with this guy right here, we can actually count any even number that we want to. This version right here is actually a 16-bit array. 8 blocks here, 8 blocks here. And this running in a series of 8 is actually only one of these sides, and it's actually only this single layer right here. So this model, this carries a lot more information in it. This is a ton of information that we can then read. And then you'll notice if I go and if we turn this back on for just a moment, then when this glass comes back around here into the front, you will see this repeater turn off. There it goes right there. So this is a way that we can use this to read information and have it either on or off. We read this out. We can have lamps. We can turn pistons on or off. Lots of things that we can do with this. So the problem here, of course, is this does violate some of the rules of Romedy. Very expensive to build. 32 pistons here versus I think 6 pistons for this guy. 14 repeaters here versus somewhere in the neighborhood of 20 repeaters to build this. So those are pretty similar. But the pistons it's an expensive type of thing. The other thing is this is reasonably difficult to build. This is not necessarily idiot-proof. This did originally take me a few tries before I understood how this thing really works. This I feel like is fairly straightforward, easy to troubleshoot. If you make an error, it's reasonably simple to go find it. So, as far as I know, this is actually pretty lag-proof, which is impressive for a machine of this size. Pistons are actually pretty reliable when it comes to lagging. It's just a matter of carrying the signal to them, which gets a little buggy. So, yeah, not too bad. So this is just a little quick look at memory arrays. 8 digits for me seems to be kind of a magic number, especially when it comes to elevators. I will explain that in the next episode. I think next time we'll actually sit down and try to wire this into maybe a rough elevator. I think that's what we'll do. And then after that we will get a little more in-depth with the Romedy elevator. So yep, thanks for watching. Appreciate it very much, and see you soon.